The largest explosive eruption of 2026 so far is actively ongoing and is now in its 17th day, just not in the location one would expect. To view it, all you need to do is head to Papua New Guinea on satellite imagery and look away from landmasses and regional islands, zooming into these coordinates in the central Bismarck Sea. There, the recently named Titan Ridge Volcano is producing a major submarine eruption from great depths of 550 meters or 1,804 feet below sea level, creating vast patches of water discoloration visible on the surface and widespread pumice rafts. Despite its depth, the eruption is energetic enough to not only cause an eruption plume to rise all the way to the surface, overcoming vast atmospheric pressure, but also then rise up to 28,000 feet or 8,534 meters above sea level. Speaking of this pumice that has been generated, while this is by no means an official advisory by myself, from low-resolution satellite imagery as of May 24, 2026, I noted quantities of floating pumice confined to at a minimum this 25,000 square kilometer patch of ocean, where it poses a potential hazard to all shipping traffic and boats with some form of engine. While these pumice rafts, which I estimate solidly cover about an area of 195 square kilometers or 75.3 square miles, could be as much as 16.4 feet or 5 meters thick of floating volcanic rocks, they could also be as little as 3.9 inches or 10 centimeters thick. Regardless, a truly immense amount of pumice has been erupted, which most likely ranges in the 19.5 million to 195 million cubic meter volume range. While the plume height generated from the two erupting vents spaced about 2,500 meters apart has been variable, any time the resulting eruption plume rises above 20,000 feet altitude, greater volumes of pumice are seemingly emplaced around the volcano than on days with lower eruption plumes. The aforementioned vents originated on a southwest to northeast trending submarine ridge which itself rises 500 meters above the ocean floor, and a dike of underlying magma is almost certainly involved beneath the ocean floor to have a pair of vents perfectly follow the orientation of the submarine ridge. This, regardless, is almost certainly building large masses of lava and pumice around the two vents, creating cones that have risen closer to the surface. However, despite what some have speculated, in my opinion, there is zero chance for this eruption to create an island anytime soon. The water here is simply too deep, and no submarine volcano has ever risen more than 1,000 feet during a singular explosive eruption. I mean, there is one example where a submarine eruption created a nearly 2,700 foot tall mountain that didn't exist beforehand, but that 13th month-long eruption far off the eastern coast of Mayotte was purely effusive and truly abnormal. So I do expect the seafloor to suddenly be 50 to 100 meters shallower in some spots, but that's a far cry from creating a brand new volcanic island. Sorry to disappoint. And now, some purely opinion-based analysis which will be noted as opinion when this yellow square is present on screen. The good news is that despite many worries from locals that the Titan Ridge volcano will cause a carbon copy of the Hunga Tonga Hunga Ha'apai eruption in 2022, there's no chance of this. Hunga Tonga had a history of very large explosive eruptions recently spaced 1,000 years apart alongside a massive caldera that marked where it had previously subsided. The Titan Ridge volcano does not contain any calderas and in fact shares many features that you might expect to find in a volcanic field on land, where many vents are spaced apart from one another rather than most eruptions originating from a singular peak. The only reason that the Rabaul Volcano Observatory noted a theoretical chance for small tsunamis is simply a case of, we don't know what the ocean floor currently looks like, we don't know how much material has been added down there, and we don't know if that material is highly unstable, but it theoretically could be. Thus, if parts of this new material slid off the submarine ridge in an underwater landslide, it could displace enough water to generate a localized tsunami. However, that is highly unlikely in my opinion, just technically possible. That is the end of my purely opinion-based section, so let's move back to some facts. It does appear that the intensity of the eruption has declined since May 21st, and one marker of this are the various volcanotectonic earthquakes that have struck leading up to and during the eruption, as these have notably decreased in the last week. While normally the section of seafloor the eruption is occurring from would be undergoing some form of extension, meaning you would expect normal fault earthquakes, the volume of magma which intruded below the ocean floor has seemingly temporarily reversed this motion, creating compression and compressional reverse fault earthquakes. But since less of these are now occurring, it suggests a decreasing magma supply. Stay tuned for more updates. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.